Welcome to this lecture on web application development. I am Klaas. You can view this presentation online by yourself via this link, and also on Canvas there's a link. So in our knowledge and data course, the final question is how we can build an application using all the information we gathered and we modeled, and then we created rules for this. We finally can put it in a triple store, and we can integrate it with other knowledge, and then we can query it and build an application for this. And we use a semantic web application to visualize our knowledge and to do inferencing and do lots of stuff and interaction with it. So during the physical lecture I asked who can build a website. So this is what we will do, building a website using knowledge as input. And building websites, the World Wide Web is the basis of the semantic web stack. So you see here you have Turtle, RDF, OWL, Logic, etc. But then at the very bottom we have the web platform, the World Wide Web. And that includes technologies like URIs, Uniform Resource Identifiers, HTTP, the Hypertext Transfer Protocol, Unicode Authentication, etc. So the semantic web is built on top of the existing World Wide Web stack. It's an extension of it. And we'll today discuss the basics of web development. So who remembers Tim Berners-Lee? So Tim Berners-Lee is kind of the inventor of the existing World Wide Web. So he created HTTP and HTML, the concept for these. So he created the Webserver at CERN to share documents about physics for the Large Hadron Collider. And he then continued to promote the semantic web. So the World Wide Web was proposed by Tim Berners-Lee as an information management system to manage all the information in physics documents. And there's a nice diagram about this, how you can organize all the information surrounding documents and the documents themselves at CERN. You have a World Wide Web consortium that develops open standards to ensure the long-term growth of the web, the World Wide Web. So this is about HTML, hypertext markup language, and then CSS, cascading style sheets, which is about layout, and HTML about content-wise tags. And then there's also some standards about JavaScript, but JavaScript was not invented or proposed by the World Wide Web Consortium, but they nevertheless want to make standards for it. And then also the World Wide Web Consortium talks about the semantic web. So this presentation itself is a web page, and web browsers are commonly used to read HTML and CSS and execute JavaScript. So a web browser is an interpreter and a renderer for HTML, the hypertext markup language, and other markup languages as well, like XML, for example, the extensible markup language. Also interpret and execute JavaScript or VB script, which is, don't try that at home, and many other scripting languages. So JavaScript, and then it sends and receives and interprets HTTP, the Hypertext Transfer Protocol, via get, post, put, and update commands. And also it gives you status updates. For example, a 404 status is that a website you're trying to access is not found. So the Hypertext Transfer Protocol, it uses get, post, put, update, which is similar to when you have database queries, SQL queries that have create, read, update, and delete, and also similar to Sparkle queries, which also have select and update, etc. So we will now focus on get commands, HTTP get commands. So in my browser URL is a get command. So you see some domain, slidewiki.org, then presentation, some identifier, some name, and then at the end we have a question mark, and then it says language is EN, which is a shorthand for English. So this is something, this entire string is being sent to a web server, and this HTML, which I can inspect, is being sent back. So here I right click on some part of the HTML and I say inspect, and then here below I see the HTML elements, and I see that HTTP is in a span element, and it has some style and some text decoration, and then the span tag is closed, and you see HTTP, which is the actual text being shown, and then the tag closes. And again, I can do this for this picture, and I see a surrounding div, and I then see, let's see, I see the, well, I didn't click on this picture, I clicked on my surrounding div, but you see me going through the entire source of this web page, and I see an image tag, and I see that this is an image with a certain source with another URL or uniform resource locator, and again I can access this via a GET call from another server, a file server.slidewiki.org. So here another example is a GET call to GitHub, which stores code, and if I copy that, open a new tab, and I paste it, I will request some page which shows pools, and then I have a certain query, and this query says is a PR and is closed, and you see a percentage sign 3a, which is a HTML encoding for a space. So basically my query is space PR plus is closed, and that is a variable I'm sending to the server, and based on this variable I get different results. So if I click on open, I see that the query is now open and is a PR, a pull request. Another example is the natural language processing server on nlpservice.experimental.slidewiki.org, and I do natural language processing for a slide deck, namely 3871, and I have some confidence interval that I'm sending. So you have here question mark DWP spotlight confidence for slide, and the value is 0.6. And then when I do this, I am retrieving natural language processing results, which takes some time, so I will in the meantime continue. But the generalized form is that you have some domain of a website, you access some script, and you give it some input, which are then variables. So variable 1 is value 1, and variable 2 is value 2. And if I, for example, I'm looking at something, if I give some variable that is incorrect, then I might get a 500 status back that there is an internal server error, that the script that accepts these values has an error. So we will also use HTTP to access the Spark query endpoint. So in our course we use stardoc as a triple store, and you can send HTTP GET commands to this query endpoint, and your GET command, HTTP GET command, will then include a Spark query that will be executed on your triple store, and then you will get results as a return value. So we already generalized this form to some website, some page, and then you have variables and values. And we can then generalize more for Spark queries, that we have a linked data website, we have a Spark query endpoint, we have a script query, then we say a variable Q query, and the value it would be some Spark query, for example, you start with prefix and then you do a select from somewhere. So here is a Yascui query. Query is prefix, w3c.org, RDF syntax, so I'm including the RDF syntax as a prefix, and then I do a select where something subject predicate. So this is all URL encoded, so it's not very readable. But then if I open this in a new tab, I can see here that this is already taken as input and it's removed from the URL. But this is basically what I'm then sending to Yascui, and Yascui in turn then executes on DBpedia, on the DBpedia endpoint. And then these results are here. So if in Yascui I say share this, I can see the exact Sparkle query, the exact URI that I've been sent. In this case, it was also a post request to DBpedia, but I send it as a GET request to Yascui. So my variable name is query, and then the value is prefix something. So this is the value I have sent, a Sparkle query. So that is how you connect to Sparkle query endpoint via HTTP. And you see these special characters are encoding for spaces, brackets, special symbols, because this is for security reasons that you cannot encode everything in a URL, or it is for encoding reasons that you cannot execute every language in. You cannot send every language in a URL. So, for example, this is English, but if I were to send a different character encoding or a different language in there, a different writing, for example, Mandarin in there, then my server wouldn't be able to interpret it unless I use some special encoding, which is then these characters. So, so this is how you do it via URL calls, but we can then also have buttons on websites that do these URL calls for you, which are encoded in HTML. So a simple website would be, for example, an HTML file. So similar to this page. So it starts with doctype HTML, HTML tag, and then a header which includes the page title and some links to style sheets, and then a body element which includes the entire page, and then div elements, which are small sections of your website which can include other things. And then we can have sections and header 1 and paragraphs, etc. And you can open this, you can store this on your local file system and then open it in your browser without having a dedicated server. But remote web servers allow you to access hypertext markup language stores filed on this web server, and then you use an HTTP address in your browser, like website.org, to access an HTML file stored on the web server, which will then be downloaded to your local browser and shown to you. And then this file is then accessed via the internet or an intranet or your local network. So a web server is a program to read and send HTTP, similar to your browser in a sense. And then when you access a website, you actually access files stored on the web server and via this HTTP address. So you send a request via HTTP to some HTML page, and then you have special programs on your web server to serve these files, to give them to you for download. For example, Nginx, Apache, or Microsoft ISS. If you access http://website.org, for example, some domain, it is translated to an IP address by your domain name server. For example, it could be 127.217.19.206. So if I access this IP address in my browser, then I go to Google suddenly. So it also works the other way around. So this is the address of a Google web server that shows you the Google search engine web page, which is again in HTML. So I can inspect this and I see some image, and I see some style, and I see some text, etc. Your local host, which we will use in the assignments and the final project, is 127.0.0.0.1 or local host, and then you can have some port number, so you can run multiple web servers on your local host. By default, port 80 is used for HTML. So if I again use the website of Google, I paste it, and I instead say port 2000, then I'm not sure what will happen. Then it doesn't work as well because it is on port 80, and port 80 is default. So you see now I load it. Or 8080 is sometimes default. And this is especially for HTML pages. So you can also, you have different ports, for example, for FTP servers or for mail servers. The latter part of the URL, so you have website.org/main/site/index.html, usually corresponds to the file plus directory structure on the web server, but you can also configure the web server to redirect from a certain URL. So it does not always represent the exact directory structure. Dynamic web servers, dynamic websites are also things you can do on your local machine. So you have JavaScript, client-side scripting language, in script tags, in your HTML, or you have a dedicated .js file, and you can then open it in your browser, and there can be dynamic interaction like alert boxes or messaging or something with loops and if-for statements. And I use JavaScript as an example, but there are many more, like VB scripts, and you have lots. You can run Python server side as well, client side as well, I think. Commonly, if you access web pages on the internet, then you have your browser, you send an HTTP request, then you download the HTML and the client-side scripting language, like JavaScript, and it's executed on your own machine, and then the JavaScript can directly access your HTML on your machine without having to ask further information from the web browser. And then on the web browser itself, you might have Node.js, which is client and server-side JavaScript, which is very powerful. Or for Python, which we've used extensively already, you have Flask, which is a mini web server, or Ruby on Rails, or PHP, for example. So these are all program files, code on your web server machine that are then executed on the machine, and the results are, for example, output in HTML or used in your JavaScript file that you then load on your local machine in your browser. Usually, if you want to have persistent data, you want to store it somewhere. So you have your browser, then you send some requests, HTTP requests to your web server, and then on maybe a completely dedicated different machine, or on the same web server, you have some database, and you have special query languages for this, or you can also have I/O, input, output, read, writes to a local file system, because a database is in a sense a optimized file system. Or you can communicate from your server-side scripting languages to your database via JSON, by sending and retrieving JSON objects, or sending and receiving HTTP. So a database server can in itself also be accept and return HTTP. But we will focus on Sparkle and the Stardock Triple Store. And from a Stardock Triple Store, as a result set, you can get JSON back, JavaScript object notation, which is quite powerful because it's a nested array and you can easily read out the results from there. This corresponds to a 3-tier architecture. So you have layers, you have the client, the presentation layer, the logic, the business logic, or the programming logic, and then the data, which is, in this case, Stardock. But this is traditional, but you can have very flexible architectures nowadays. So you can have your client browser send requests to DBpedia via client-side scripting immediately, or you can connect to your web server, which then connects to a different web server with an API route, an application programmer interface, only for data storage. So then this server can focus on program logic and be more powerful in that sense, and this database server can be replicated to store a lot of data. And then your web server can also send and receive requests to an even external triple store or SPARQL query endpoint like dbpedia. So I had an example of an external API, but it's down. The NLP service in SlideWiki. So that, yes, no, it's not down. So this website is a external API, and you can send via HTTP GET request. You can send some request, for example, NLP for DEC, and then if we do this for DEC 8037 with parameter confidence interval 0.6 and 0.6 for dbpedia spotlight confidence interval in this route. So you see that this route is also reflected at the bottom here. And we try it out, then we get an error request because this tag is non-existing. So let me try another one. And this one is also non-existing. So maybe I try it for the deck we're currently viewing. Well, anyway, so I send a GET request here, and I can also execute this in my terminal. So this is what you would normally put in your browser address bar, but you can also do it in your terminal, which is a powerful tool for testing things. So here I do the same HTTP request in my browser, and I get the same result, the 404 not found message. See? So this is the same as this return message. And as an example of external services, we already saw the Yasui query. So I have the URL here. If I click on it, I can see that the parameters are loaded here, so it's a very large query. And I want to, I construct a query where I get public universities funded in the Netherlands. And I see the University of Groningen, the University College Maastricht, and I can then import this data in my triple store, or I can import it in Protege as TTL results. So this is stored. This query is then stored only in this GET request, and as a result I get this back. So these GET requests you can also use in your programming code to get the same results back. And you can do the same again in your console using curl, or in your programming code by saying that this is a post request and we want, for example, turtle back. So we accept text turtle as a return result. So for a semantic web application, we first have lots of data sources like tabular data, dbpedia, SPARQL. Then we use Stardock, we have integrated knowledge, and via SPARQL we can access it, and then we have a website, web servers. And then on our client website or web application we can access it and visualize it. So for our final project and for assignment 5, we have a triple store, and then we have SPARQL to access the triple store, and we have server or client-side scripting, Java, JavaScript, PHP, Python, Flask for Python, and then we also do HTML and CSS to make the results pretty. So not text only, but we put it in header 1 tags and in diffs and paragraphs, etc. And we give it a color, and we put it in a table or in a nice pie chart, for example. So when starting on this, we need to know some HTML, and then we can do JavaScript interaction with the HTML. So this is an example of an on-click event. So first we have some HTML, then the body of the HTML has a button, and it has an on-click property, and it says my function. So if I click on this button, then my function will be executed. We have an empty paragraph, and then a script with the function in it, the JavaScript, and it says hello world once you click on it. So let's try this. See, here we have the same HTML code, and then if we click on the button, we see hello world, which is here, and we replace the inner HTML of something with ID demo with hello world. This is the element with ID demo, and we put hello world in there.